and this is our last lesson for this module, as well as because you have a review and quiz on Monday. But this is the last lesson of the module because next week you have your review and quiz, and then following that you guys will be working on a project for a few days. So in this unit, we're going to sum up the rest of the concepts for least squares regression. You had yesterday where you actually looked at the least squares regression line, like looking at this data right here. If I were to zoom in a little bit, let's see if my computer will let me. I think I actually need to get into it. Just a second. Here we go. When I zoom in here, I put a few values here that you could look at and see the correlation. Like in this one, this has a very weak correlation. I couldn't even tell you. The R is probably closest to 0. In this one right here, it looks like the data is in an upward linear trend. So it looks like that would have a moderately strong, not super strong, but a moderately strong positive linear association, maybe like an R value of 0.8 or so. This one tends to be even a little bit stronger linear, but it's going to have a negative R value or a negative slope. In this one, I would say it has an R value of maybe like 0.85 or so, maybe 0.9, but there is definitely a negative trend downwards. That shows you how we would talk about those. This right here is measuring chocolate consumption, and here it's by population size, like 10 million people. Then you would multiply by this. So this shows the chocolate consumption and the per capita or million of people within these different countries. And you can see that there definitely is a positive trend here. What that would mean is that as you increase chocolate consumption, you are also increasing the population of, what is this? That's funny, Nobel laureates. Okay, so that is, they're trying to make a positive association between those two things. I would obviously say that that is something that there are probably a lot of extenuating circumstances there. But the correlation is R here. R is 0.791, which means that there's a moderately strong positive correlation between those two things, okay? Okay, so that's what we've done a little bit so far. I wanted to talk about those because today we're going to talk about the coefficient of determination. One more time, we've looked at this R value, which is our correlation coefficient. Correlation coefficient. I call it correlation. I don't usually use coefficient, but correlation is my R value, and it only measures the strength and direction of a linear association. So this would be a moderately strong, positive linear association based on that R value. Getting into the actual notes for today. So now let's talk about the correlation coefficient because they are related to the R squared. Let this load for a second. Okay, there we go. So here, R squared is going to be what we call our coefficient of determination. And it's going to tell us the fraction of variation in the values of Y that are explained by the least squares regression line. Okay, so this is really a sentence that you memorize. That's why I have it in highlighted in yellow, because with R squared, what it tells us is how much variation in Y's can be explained by that least squares regression line. So it's R squared. So in the last example that I was just showing in the module, in order to find my R squared value, my coefficient of determination, I would take my 0.79 and I would actually just square it. That would give me a value that is lower than 0.79, but here it would, if I had an R squared value of 0.615, what it would mean is that 61.5% of the variation in my Y's, this has to do with the scatter around that line, is explained by the least squares regression line. Okay, so the distinction between explanatory and response is essential for this one. You need to make sure that you have that correct. A change of 1 standard deviation in X corresponds to a change of 1 standard deviation in Y. I'm going to de-emphasize that and tell you that you guys don't need to know that. But here is an important one for you to know. The least squares regression line is always actually going to pass through the point X bar, the mean of your X's, and the mean of your Y's. If you add up all your X's and divide by the number of of x's that you have, then that mean would go here. If you add up all your y's and divide by the number of y's that you have, you would get a mean right here, because that's how we calculate mean. And your least squares regression, not only is it cool that it makes the squares of those differences as small as possible, but it also passes through this point every time. It's a pretty amazing thing. And then number 4 is again that sentence. So with this unit, you're going to be looking at an r squared value, and you're going to be talking about the fraction of variation that's explained by the least squares regression line. I'll ask you to do this once in homework, and I will ask you to do it again one time in the project. So just make sure you understand that sentence. 61% of the variation in your y's is explained by the least squares regression line. Okay, so let me pop back over here. If I had a least squares regression line here, I would say for this one, and in fact, I'm going to take my 0.79. I have a calculator here, so I'll tell you what the r square value is. I would take 0.791, and I'm going to square that value. I get 0.626. And the way that I would say that in relationship to this is 62.6% of the variation, like the distance that these are from the line, the variation, how much they vary from the least squares regression line, 62.5% of the variation in my y values is explained by the least squares regression line. So if I actually put the language here, it would be 62.6% of the y's, which is Nobel laureates, can be explained by the least squares regression line in relationship to your chocolate consumption. Pop over and try the homework problem. I do have an explanation down below.